All right, guys, welcome to our Wednesday lesson. So in this lesson, last lesson, we've learned how to interpret displacement time graph in terms of what does it actually represent: constant speed, stationary, constant speed going in the backwards direction, accelerating, decelerating. And yeah, so the key thing is we need to look at the label. It's displacement time, and the gradient is tell you the velocity. Okay, if gradient is positive, going in the positive direction. If its gradient is negative, it's going in the negative direction. Okay, sweet. So now we got an analyzing displacement time graph for this lesson. So basically, now we know the gradient is the velocity. So now we just need to calculate gradient in order to get the gradient. Okay, all right, sweet. So let's have a look at the example we have. Is the first one is a straight line. We need to find the velocity. So if it's a straight line and then it's a constant velocity, so we can choose from any point, 2 points, to get my rise over run. I can start from 0, 0 and choose another point over here, or I can choose 2 point here, 2 point here, 2 point here, 2 point here. It's not matter where I choose these 2 points because the whole line is straight line as long as my 2 points are on the line. And you got to remember that we have to do 2 points. You can't just do 1 point, okay? If you're doing 1 point and you're assuming there is a 0, 0 point, does it make sense? So if you got a line going up like that and then like this, if you are calculating velocity over here and you just use this 1 point and then you're calculating the whole thing, not this section over here. So make sure you always choose 2 point, okay? You see the first one I've chosen is 2 and 50. And then second point is 400, okay? So then I put it in my calculation. Rise is 100 minus 50 and then divided by run, which is 4 divided by minus 2. So then get 25 meter per second. And this is the constant velocity. So the instantaneous velocity in any point over here is also 25 as well, okay? All right, so next one, I'm choosing 2 points. The first point is 0, 20. And the second point is 5, 0. And make sure you use the final minus initial. And so the final, the distance is actually become 0. It has come back to the 0 point. And then originally it started at 20 position, okay? So going backwards. So then I use my final minus initial, 0 minus 20. All right, final time is 5 minus 0. So then I get negative 4 meter per second. And this negative 4 means this velocity is going in the negative direction, okay? So coming back to 0, okay? All right, and then if we want to calculate instantaneous velocity, there are 2 situations. The first situation is easy. If it's a straight line, if you want to calculate, say, the instantaneous at this point, okay, this exact point, you just need to calculate the section, this whole section. You choose any points from this whole section over here because it's a straight line. Say this point, this point, this point, this point, this point, this point, any 2 points, okay? And then you calculate this constant velocity and say you get 10 meter per second. And then this is 10 meter per second, this is 10 meter per second, this is all 10 meter per second because it's a constant velocity, okay? All right, so, and again, if the start from 0, 0, then you can use 0, 0 point. You just use this rise over this big run, okay? But if it has make a turn, then you can't use 0, 0 because the turn, let's say like this. This start from 0, 0 over here, and it went up like that, and then you went up like that, you have to make a turn. If you want to calculate the instantaneous speed, say, of this point over here, you can't use this 0, 0 point because 0, 0 point is on this section. So you have to choose 2 point on this section over here. Do a little rise over run over here like that. Okay? On this one, you can do a rise over run from 0, 0 here. That doesn't matter, okay? All right, just make sure you get that. Okay, and then the hard one is the one where you have to deal with a curved line. If you want to calculate the instantaneous velocity of the curved line at a particular point, so you have to draw something called a tangent line, okay? So how do you draw a tangent line? It's a little bit complicated. So you can pause this video here and I will make another video and actually show you how to do that because it's quite hard. I mean, you're supposed to learn this in math, but what from my previous experience is lots of students actually don't know how to do it very well. So I'm gonna expand it in detail and draw it for you guys, okay? So you can have a look. So let's leave this here. So stop the video, watch the other video, and then we come back to this one, okay? All right, so then Next one, if we want to calculate the average velocity of the whole section, and then we just need to find the total distance divided by the total time. We don't care how it's curving in the middle or whatever. We just need to find, okay, this is the period. I find the number over here, and then I find this number over here. I just use these two numbers minus each other, divided by the whole time. I don't care if it's curves in the middle or what. So the example I give you is 100. It started from 0, 0, and that's very important, okay? So start from 0, 0, and then it's 100. Distance moved 100, time taken 5 seconds. So 100 divided by 5, and I get 20 meters per second, okay? And then the second one, same thing. For distance, it went up and come down. If it's asking calculate out average velocity, because the displacement is actually 0, because it went up and it becomes 0 again. The total displacement is back to 0. So it's 0 divided by 5, get 0 meters per second. But if you're asking the average speed, it has gone up 20 and come down 20 again. So that's actually have gone 40 meter, okay? So then we use that 40 meter divided by the total time taken, which is 5 seconds. You get 8 meters per second. Okay. All right. So for this part over here, there's actually a lot of questions to practice. So I'm gonna give you guys today's lesson. You can just practice this part, and probably another lesson tomorrow. You can continue work on that. So the homework is it's a little bit different from the booklet that I have over here. So you're gonna be working on. So that's page 8. Gonna be working on page 6, page 7, page 8, page 9. Okay, so there is 4 pages. Page 6, 7, 8, and page 9. Okay. Especially the curved ones, so you gotta be a little bit careful. So have a try of it first, and then I'll upload the answers onto the onto Google in the next lesson. Then you can check out the answers later. Okay. All right. So now I'm gonna make another video for you guys in terms of how to draw tangent lines. Okay.